This is a future microscope stand slash camera slider, and I've already tested it with the stepper motor mount, and well, I'll show you what I discovered there, which is exactly why I like 3D printing so much, because I can just put what I think makes sense and then print it while I work on something else, and then I get the real part and I can see where I was way off, and then make some changes and do it again. So it's kind of a really nice way for someone like me who likes to like see, feel, touch things, to kind of see how stuff goes. So this is that part that I printed the other day, and trying to make it for multiple options. So as an example, you can run it with the timing belt, but as you probably could see there, what I didn't account for is this bump on the stepper motor. It actually has this sort of raised ring right there. So I didn't make a counterboard hole for that to go in, so that wasn't working. Hole placement worked, and what was actually really neat is how I thought to attach this, which I will just show you here. I took and went through from the bottom there, so there you go, you can see through. Put holes all the way through the shaft openings so that you can stick a screw all the way up through there and attach it that way. And once you get that in there, there's still clearance for the shaft. The only downside is that obviously the shafts have to be installed after the motor, but I thought it was a fun little thing to test. But now I want to see if the inside diameter in here is big enough for this 3/8 12 shaft or threaded rod that I've got. So this was the first sort of test that I did. I will see if I can show you how this works. So this is just a basic little slider. See, is that in focus? There we go. So this is just a basic little slider that I made. Works really well, but that was my version 1. This needs to be a little bit wider, and you can see here's the threaded nut that transfers, the motion. What I tried for here is like a sandwich version where it squeezes it together, but you can possibly see from there that there's a bit of an angle where it's tighter at the top than at the bottom. So that's not ideal because that's putting a little more pressure on the shaft, which is making it not slide as smooth as it could. And the second thing is that it's just too narrow, so it has, if you were to apply any force there, it's gonna bind a lot quicker. But anyway, that was a quick version 1. I also did this shaft collar, which works totally fine. Now I'll show you a bit about this. This end, it goes all the way through. This was just an earlier piece that I made that I used as a handle then. But this goes all the way through, just like this one here. And that's where this is sticking out to attach a gear, motor, handle, whatever. But then at the other end, that is capped off, so it only goes in about this far. So that acts as the bearing and also the stopper on that end, so that the only stop you need is this piece here. Now with this, the only 4 pieces that are not printed or nuts and bolts are the 2 shafts, which are 3/8 by 12 inches, the threaded rod, which is 3/8 12 threaded, the nut for the threaded rod. That's it. Everything else is just sort of using these plastic pieces as the bearings and the frame and everything. And I'll kind of show you that while I take that apart and then test this with some of these other pieces. Actually, I guess we can test this. We can do this first test without really anything else. Let me get it focused in over there. All right, so it goes in and spins somewhat freely. Again, the reason I'm doing this because I wanted to see if I could do both a timing belt passageway and also the 3/8 inch threaded passageway. I don't know if it's a good idea, but while I was printing, yeah, I mean, that's pretty smooth. While I was printing the whole thing, I thought that would be nice to try. All right, we can take this apart now and then see if the shafts are going to fit in there. There's that. And these just squeeze the shafts a little bit tighter. And I'll show you how these work in a second. Let me see if I can. I wanted a looser fit. The first ones that I did were a pressure fit and just crazy tight. Okay, so I think you can see in here there's some square nuts that are just slid in there, and then M3s come down through the top, go into the square nuts, and then I did these two slits in the face to squeeze on the shafts, and I left a little bit solid material around here to keep that from getting squeezed. Now, you know, this isn't exactly my own original brilliant design. If you look up here, if you look closely at that, you'll see sort of some similar design patterns. But, all right, let's see if this is a suitable replacement for that. Ooh, perfect fit there. That's really smooth. Okay. Yeah. All right, that's actually good. But I didn't put any locking mechanism in this one, so I can't clamp that down anymore, unfortunately. But again, this is just to kind of test things, so now let's add it to here and see how it's all sort of looking. Well, the idea, if I didn't mention what this is that I'm making, I'm trying to make a camera stand. So it's a camera slider and also a vertical and horizontal camera slider, which is why I'm using the threaded rod for this version. A lot of camera sliders use a belt drive, the timing gear and belt, but the downside of that is that they rarely have the power to lift up and down, whereas with the threaded rod, you can go, and if you look on like the Prusa Mini that I have, for the up and down axis, they're using threaded rod. For the going across axis, they're just using a belt because it doesn't have gravity at play. But here you can see kind of how this is looking. So this is a 40 by 20 aluminum extrusion, and it just slides right in there, and it's a snug fit. I mean, there's no play. I did do a bit of a chamfer on the back side of this in case I need to make it easier to go on and off, but let's see which one's my handle one. Let's put the handle on here and see if this is working. Okay. Get our lock shaft little collar back up there. I was actually surprised with how little play I was able to leave with this, with just using the PETG printed parts. I have some nylon some nylon sleeve bearings that I thought I might need to use, but this was actually a lot of fun to do this way. So once I get it all set up, I'll do some wear tests. All right, so there we go. Now we are set up, and we've got the added stability of that 20 by 40 millimeter extrusion, and this is starting to look pretty nice. See if I can get see what all design changes I need to make. Definitely, obviously, I need to make it where I can mount that motor in there. But also, so that's just for the belt drive for this version. I gotta decide if I want to mount. I was thinking about maybe mounting the motor over here. There's one option. Obviously, then another option is to mount it on the end somehow. But I gotta figure out what I want to do with that. If I mounted it here, I'm thinking to just do the timing belt gear, printed timing belt gear to go on the 3/8 threaded rod, and then put this one on here, and then just do a little connection there, which I think would be nice. But I might also just do a handle first, so get the other end of these print another one of these tomorrow, just with that one change. Because yeah, this is actually, my concern was that having the very narrow, or the very limited surface contact between the threaded rod and this block was going to cause a problem, but this is actually really smooth. It's actually, I guess, smoother than the other one because of that, because it has even less there. So all in all, that's pretty exciting. Since we're doing this, let's actually try this end block over here, because it's yeah, you know what, it's not, is it the right, I think it might actually be the right height. So this could be fun. Let's see if this gets us fully attached to the extrusion, the aluminum extrusion. I did the aluminum extrusion because I really like it as the backing, and it was convenient to be able to just order yeah, I'm gonna need to tighten. Gonna need to add tighteners. So that's another thing. I need to add the offset here, and I need to add tighteners of some kind for attaching these shafts. These tighteners worked great, so I'm not sure if I'm going to just scrap the belt option or what. Okay, yeah, I did shift the, yeah, I changed the offset, or the distance between the extrusion and the shafts between these two designs, so this one's not actually gonna fit in there. And also, I printed this one wrong. I printed it like this. If you saw a little short video I did the other day of the fail, so you can see there's some loose stuff down here, because you can't go with just a right angle overhang. You gotta do angles, but also I think that collapsed my holes. So that part is probably pretty much worthless. But here, since I've got this one off, you can see that doesn't go in very far. Well, you can maybe see the lighting and the focus, I know isn't great, but that's how that works. So put that one on for now, so that we're still functioning, and push those flush. Get that snug fit. Not sure why that's not wanting to go in there the rest of the way. probably save you the time. Cut the video off here, and then next time hopefully I'll have a second one of these blocks so we can assemble this properly, and then get going on a longer slide on the middle so we got more stability and better mounting points. So yeah, that's it for this video, and next video hopefully have for sure an end block and maybe a slide going on here.